This one is actually described online in my YouTube videos. One of my YouTube videos, actually several of them. But maybe we'll go take a look at this. So if we double click on main here, what we'll see is within main we have a population in a familiar fashion, but we also have stocks and flows. It's specifically their stocks and flows associated with costs, both discounted costs and sort of undiscounted costs. And we also have stocks and flows associated with quality adjusted life years lived and life years lived by the population. And the rates of flow into these are determined by a set of quantities. The most complex of them, well, some of them are quite simple. For example, life years lived. Does anyone have a sense of how do you compute life years lived for population? We wanted to compute over a 50-year time span. What was the number of life years lived in that 50 years? So it's person years. So the number of person years lived. And to do that, we could just so at a more precise level yet, if we consider the fact some people may not live for a full year or what have you, we have the integral of the population up over 50 years. So that population may be varying in that 50-year time frame. Some people die, some people come in, and we total it up over that time. So we take the area under the curve in an intuitive sense. So here's the population that's fluctuating, and this is up to 50 years, and we take this area here that's under the curve as our life years lived. And you'll see actually that this does exactly that. So if you go to, for example, new life years lived here, this flow into life years, you'll find that that's just the population size. Now we'll be coming to this, to what this means, but it's what we call a population statistic, and it's defined with the population. And you can define as many as you want with custom names. Oh, excuse me, this is not. The others are. This is population.size is just the size of the population right now. It's just asking population, how many people are in you? Quality adjusted life years is a little bit more sophisticated. This uses a population statistic, something defined in the population. Over here, we have statistics we can define, and cumulative quality of life just totals up the quality of life of different people in the population at a given time. It's essentially the sum of people weighted by each of their qualities of life, and quality adjusted life years is just the integral of that. Just the flow in, which means it's the integral of that flow. The most textured of these ones, however, is a cost calculation, which includes contributions of two sorts of costs. Type of cost one, actually, well, two broad sorts of costs. Contribution one is costs associated with intervention, on the one hand. Another sorts of costs is costs associated with health service delivery. So we're going to have some interventions that we're going to be examining the cost effectiveness. And here, we want to total up both those costs that it takes to roll out those interventions and propagate them. And we also want to total up the costs associated with health service delivery. So we're serving the population. Now, the two are coupled, of course. If you have this intervention, maybe it reduces, in this case, it's the burden of a sort of very stylized chronic disease. I think I did diabetes. And basically it lowers the intervention affects the recovery rates of diabetics back to a normal glycemic state, and thereby it lowers the chance that a person will develop type 2 diabetes and develop onto end-stage renal disease, for example. So here we have health services costs coming in as well that we want to consider. So when we consider the costs imposed by an intervention, we want to consider both the savings that intervention confers, because it lowers the number of people eventually presenting end-stage renal disease, say, in this case, and we want to consider the costs it takes to achieve that intervention, to perform that intervention. So both types of costs are considered
health services costs are themselves divided into sort of two types of costs. One type of cost is a cost for being in a certain state. So given that you're in a type 2 diabetes state, maybe you have a cost per year that you exert on the healthcare system for insulin that you may take, for metformin, other types of medication, etc. So there's a cost per year of a given person being in a type of being in this sort of state. And then there's moreover a cost associated with certain types of events. So specifically, when someone develops, for example, is given a transplant, so they receive a transplant, there's some cost to that operation that's also modeled. Okay? So both those sorts of costs are taken into account. Without going into all the details of this, again, this is all on YouTube. You can listen to me describing. In fact, I build up this model, this very model, sort of interactively. But what happens is that all these costs end up flowing into these stocks and flows at the main level. So here we have agents, and main is computing these sort of global stocks and flows related to costs and qualities and discount costs, that sort of stuff, computed up from the population level. So here we have sort of high-level system dynamics, and what's driving that is really the agents in the population. What the other component that's a little bit perhaps going to be new to you is we make use of a parameter variation experiment to in fact calculate the incremental cost effectiveness of an intervention. So we undertake an intervention and we have a baseline scenario, and this parameter variation experiment runs one after the other. So first it runs the baseline, then it runs the intervention, then it takes the difference in qualities and it takes the difference in cost, and it computes, for example, the incremental cost for incremental quality gain, and similarly for life years, etc. So here we have a use of a parameter variation experiment to run two conceptual scenarios, and take the difference between the two. And the code to do this is in here. So we're for example, computing the life years lived for each successive scenario, the qualities, the undiscounted costs, and the discounted costs. And then if we've run the final scenario, in this case it's just scenario 2, 1 and then 2, we perform a cost effectiveness calculation that sort of considers the qualities of the first scenario and the qualities of the second scenario, and takes the difference between the two and some of the costs. So this is an example of a model that uses system dynamics and uses agent-based modeling, but in a rather different configuration than the last one we saw. Anyone want me to answer any questions about this, bearing in mind that there is material in detail showing exactly how this is built up, discussing how things are done? Anyone want me to answer some questions about this right now? Okay. So that was a sort of a second hybrid model I wanted to bring to your attention. It's a basic health economics, and I'm going to stop this.